Let's look at some examples of exponential growth and decay and some application. So when you are trying to figure out if a exponential equation is growth or decay, you're going to want to look at the b value. So this is our initial value, and then this is our rate. This is our b. This is what we want to look at. If that value is in between 0 and 1, it is going to be decay. If we want to know the percentage, we have to change this decimal into a percentage by shifting the decimal over 2 places. But this 91% does not mean that that's the rate of decrease. 91% decreasing would be pretty quick. We have to figure out how far away from 100% 91% is. So I'm going to do 100 minus 91, which is 9. So the answer to this question would be that it's decay and it's decreasing at a 9% rate. The next one, again, the 25, the outside part is my initial value. Maybe if a problem was talking about an initial amount of investment or an initial amount of population, this is where I would start with that. But we're focused on the rate and the growth or the decay. So I'm going to focus on my b value. If your b is greater than 1, then that's going to be growth. This time I need to move my decimal over 2 places, just like I did on the last one. And I'm going to subtract 100. I need to figure how far over 100 it is. So if I do 107.1 minus 100, I get 7.1%. So this would be an increasing rate of 7.1%. Here is a real-life word problem. We are investing money into an account. It earns a rate of 2.6%. We are going to compound continuously. This is important because when you are taking out a loan or investing money, you can compound in different ways. You can compound annually, you can compound monthly, you can compound biannually. There are a lot of different ways. When it's continuously, you're going to see this E, and E is approximately 2.7. That is our rate. It's kind of like how pi is approximately 3.14. So we are going to be investing money. This is our initial amount, our investment. That's going to be your P, your principal. The rate is given to us. It's going to be a percentage. We do need to convert that percentage to a decimal by moving the decimal over 2 places to the left. So 0.026 in this case. I want to find how much money I will have after the money is in the account for 18 years. So I'm just going to plug everything into this formula. I have my principal, my initial investment. E is just E. It's going to be a button on the calculator. R is our rate. And T is our time. We are looking for our V value that represents the amount of money that's in that account after this time. Now, if you're using a handheld calculator, that's fine. You can also use Desmos. There, you should be able to type in E. If you're using a handheld, there is an E button. You will often have to hit second before you hit that. If you're using Desmos, you should be able just to type E right in. Make sure it's a lowercase e. If you use 2.7 instead of E, your answer is going to be a little bit off, which is going to cause some rounding errors. Be careful when you're doing these problems in Desmos because they all have you round differently. This one has me rounding to the nearest cent, which is the nearest penny. So that's going to be 0.01 in the hundredths place. Sometimes they'll have you round to the nearest whole number, so just pay attention to the rounding. It does change from problem to problem. I'm just going to type all of these numbers in the calculator just the way it looks here, and it's going to give me the answer. Just make sure you move that decimal over for that rate. If you type in 2.6 instead of 0.026, it's going to cause problems. When I type all of that in, write out my answer. This is what I'm seeing on the calculator. I want to round to the nearest cent, so it's the hundredths place. This 7 is actually going to bump that 9 up. This is a weird case when you are rounding because when you're bumping up that 9, it is actually going to affect this number as well. So I'll have 20 cents. So I have a little over $100,000 in my account. Make sure that when you're doing these problems that your answers make sense. If I am investing money and it's in there for 18 years, then I should have more money than what I started with. Think about if you were borrowing money and paying back on a loan. Your answer shouldn't be drastically larger unless you're leaving in there for a really long time, and it definitely shouldn't be smaller if you're investing money. All right, let's do one more real life example. We're given a formula. This P sub 0 is my initial amount. Anytime you see like a V sub 0, a lot of times in physics, that's the initial velocity. That sub 0 is indicating that that's an initial amount. So the initial population, my P sub 0, is 9,700. That initial amount, whatever you're talking about, always goes out front. And it doubles every 5 hours. P sub t is the population after the time. There are two different times in this problem. One represents how often the bacteria is getting doubled, and one is the overall time that we are waiting to see what the final bacteria is. So again, we're starting with our initial amount, and then the 2 is there because it's doubling. That's just going to be part of our formula. The t is our overall time, how long we're waiting to see what that overall bacteria is. And then the d is the doubling time, because we were told that it doubles every 5 hours. So again, I'm just going to type all of this in my calculator. If you have a handheld, like a TI-30 or a TI-84, that's fine. When I type this in the calculator, I do put this part in parentheses. If you want to use Desmos, also fine. And I'm just writing down what I'm seeing on my calculator screen. Couple of things. This one does say round to the nearest whole number. So we're going to look at the tens place. This is a 5, so that does bump this up. To a 5. So I have almost 256,000 bacteria. Again, let's think about the context of the situation. We had a decent amount of bacteria, and that bacteria was doubling. So even just after 1 hour, if you double the initial amount, that's getting pretty large. 7/5 is a little over an hour, so that does make sense. I am going to go ahead and just type that in Desmos just to show you how you would do that. I'm putting in my initial amount, my 2, hitting Shift 6 to get the exponent, and then typing in 7/5. to get the answer.